Hey everyone, we're going to look at number 6 in section 1.3. We're given two functions of t, f and g. We're going to construct the compositions f circle g and g circle f, and then we're going to find their respective domains. Okay. So first of all, let's start with the domain of the function f of t. Notice we cannot take the square root of a negative number, so the value of t must be greater than or equal to 0. I can take the square root of 0. So there's the domain of that function. Function g of t, well, you're just going to take whatever the input is t, raise it to the 15th power, which means multiply it by itself 15 times, and then you're going to subtract that from 1. Do you always get a real number when you do that? Yes. And so the domain is all real numbers. Okay, again, you should be familiar with the domains and ranges of all the basic functions from pre-calculus. This sheet can be found in Brightspace in the content area under the resources module. It has a review for all our functions, including exponential, logarithmic, and trig, inverse trig functions. You need to be familiar with those, especially when we talk about the domain and range of functions. Okay, let's do f circle g. Okay, that's defined to be f of g of t. G of t is 1 minus t to the 15th power. So we're going to plug that into the function f, and the function f says whatever you plug in, just take the square root of it. So I'm plugging in 1 minus t to the 15th. I'm just going to take the square root of it. And that's it. I can't simplify this any way. Please note that the square root of a minus b is not the square root of a minus the square root of b. So you can't just write this as the square root of 1, which is 1 minus the square root of 15. No, you can't do that. Right? That's not true. That's a very common mistake students make. Please don't make that mistake. That's a bad algebra error. So what's the domain now of this function? Well, we start with the function g of t, what we're plugging into the function f. What's its domain? Its domain's all real numbers, so we're good. We don't have to worry about anything there. But the output to g of t, right, the 1 minus t to the 15th power must be what? Greater than or equal to 0, right? Because it's going to be plugged into the square root function. So 1 minus t to the 15th must be greater than or equal to 0. Well, this is not a linear inequality. This is a nonlinear inequality. So the way we do nonlinear equalities, if you remember, is we get 0 on this side, which we have, and the polynomial or whatever the function is over here, we want to do a sign check. In other words, we need to know when this is equal to 0, first of all, 1 minus t to the 15th, and then when is it positive and when is it negative. And it's only going to be 0 when t is equal to 1, right? 1 to the 15th power is 1. Notice if t is negative 1 to the 15th power is negative 1, and I would get 1 minus a negative 1. I would get positive 2. So I like to do my sign check this way. For the sign of 1 minus t to the 15th, I do a real number line. I notice at 1, that's where the 1 minus t to the 15th is 0 when t is equal to 1. So this is the t value here. And if I plug in something less than 1 like 0, what happens when you plug in 0 for t? 1 minus 0 to the 15th power. 1 minus 0 is 1. I get a positive number. That means everything less than 0 will be positive. Anything greater than 1, like again, 2, if I plug in 2 to the 15th power is a huge number, much bigger than 1. So when I subtract, I'm going to get a negative number. Bottom line is, when is 1 minus t to the 15th greater than or equal to 0? When is it positive, right, for values less than 1? Since I'm looking for greater than or equal to 0, I'm going to also include 1 because that's where it's 0. So the domain is everything less than or equal to 1. That's when the value of 1 minus t to the 15th will be greater than or equal to 0. So I can take the square root of it. In interval notation, we write t less than or equal to 1 this way, and be careful, that's what they're looking for in the achieve. All right, read that little parentheses information there. Okay, Let's look at g composed with f of x. So this would be g of f of t. Here I'm plugging in the square root of t function into the g of t function, 1 minus t to the 15th. So I'm going to replace t with the square root of t. Can I simplify this? Well, we can a little bit. The square root of t, if you remember, is the same as t to the 1/2 power. So this is really t to the 1/2, then raised to the 15th. So what do we do when we raise one exponent to another? We multiply exponents. 1/2 times 15 is 15 halves, or 7.5. But again, usually Achieve wants you to leave things in fraction form. So this would be the way to write the final result. Notice the exponent on t is a fraction of 15 halves. Okay, 15 halves again, meaning that we will take the square root and then raise it to the 15th power, or raise it to the 15th power and then take the square root of whatever t is. What about the domain here? Well, we're starting with the function f of t, which is the square root of t. So remember that domain is everything greater than or equal to 0. And that's plugged into this function, but it doesn't matter what comes out of the function f of t, which, by the way, is always going to be a non-negative number. But the point is the domain of g of t is all real numbers. So this is the only restriction we have. The domain is everything greater than or equal to 0. Okay, hope this helps.